Let me quickly introduce you to different certifications available here. Okay, so let me start with the notepad. There is a certification called as DP 900, which offers you fundamentals of Azure ML services, fundamentals of ML machine learning services. Okay, then comes DP 100. DP 100 extensively talks about Azure ML uh, service which is available on Azure platform, and this service basically covers end-to-end development of machine learning or predictive models. So this is a Azure ML service. So in today's session, okay, we will try to take you on the tour, okay, for Azure ML service. In AI, okay, there is one more certificate here, which is again important, and it is 203, which talks about Azure Synapse Analytics. Synapse Analytics. Azure Synapse Analytics talks about how can you engineer the data, specifically on data warehouses. Now here, remember, data warehouse is something which basically is for extensive data analytics. It is different than databases because databases basically are for transactional processing, but Synapse Analytics is for analytical processing. Difference between database and data warehouse can be explained in better way using the terms OLTP and OLAP. OLTP OLTP basically for transactional workload, and OLAP basically is for analytical workload. Both these are entirely different environments, and OLAP works on very large size of the data and is extremely useful for analyzing the data, mining the data, extracting appropriate information from huge size of the data. While OLTP talks about recording the data, preserving the data in the database, and querying that database entity wise. Okay, so there is a huge difference between both of them. Then comes AI. Now remember, machine learning is a part of the artificial intelligence. In artificial intelligence, wherever there is a predictive analysis, okay, there we talk about machine learning. So machine learning basically is for prediction, predictive analysis, business predictions, sales predictions, and different types of predictions. Artificial intelligence, as on today, is talking about not only predictive analysis, but otherwise in a deep learning, natural language processing, image processing, video processing, generative AI. So there is something called as a AI 900, which is a fundamental on artificial intelligence on AI, and there is AI 102, AI AI 102, which is extremely important certification as on today, which talks about generative AI, development in generative AI, development in Gen AI. Internally, these Gen AI somewhere is uh, built on the foundation of machine learning services only. That's why, in case if you complete DP 100 and thereafter you go for AI 102, that will certainly help you out. So these certifications you can target, okay, and Synergetics certainly offers say online learning for all these certifications. Some of the courses are 1 day, like fundamental courses are 1 day, AI 900, DP900. They are of one day, while courses, specialized courses like DP100, DP203, AI102, they are either 3 to 5 days, 3 to 5 days. Okay, so this session basically is to give you idea of what this particular technology is, specifically machine learning. Okay, and thereafter, after attending this session, you may think of uh, joining courses on one of these certifications, or even if you want to try these certifications with the self study, that is also possible. Yeah. So let me start with the slideshow. Azure AI, sorry, Cloud Platform, Azure ML Cloud Platform offers you extensive uh, development of machine learning models. So, what exactly machine learning is? How do you work with Azure machine learning? How do you develop, your predictive models? There are three approaches available in Azure ML to develop predictive models. What are all those three options? We will, have brief introduction to uh, two models, sorry, two approaches here, and we will have in a detailed explanation of one of them, third approach. Two approaches are, there is something called as a programmatic development. There is a second approach is, there is something called as a designer. Okay, and the third approach is AutoML. So programmatic approach basically needs extensive study of the programming language like Python. But in case if you are not, you do not have enough, or you are not willing to go with development, but still, if you want to develop a predictive model, you can go either for the designer or for AutoML. Designer is low code. Minimum code is to be written, but yes, some code certainly has to be written there. Okay, but otherwise, if you try to go with AutoML, there you will see no code development. So we will try with that also, as we have very limited time of 2 hours only. That's why we do not have a leverage of covering all the topics in detail. So we will go with a no code approach. As your machine learning, everybody knows, what is artificial intelligence is. Artificial intelligence is basically mimicking human behavior. Okay, machines mimicking human behavior, softwares mimicking human behavior. That is artificial intelligence. A platform for operating machine learning workloads in the cloud. Now, for this artificial intelligence or for this machine learning, you have to train one model. The way we train students. Students specifically initially they carry little knowledge about this subject, but as you keep training them, they understand the things accordingly. They develop their skills, and once you complete the training, you do expect them, to um, uh, uh, do the job specifically in that knowledge area. Okay, they have enough knowledge and they can do a practical work, they can do some implementation, or they can answer questions in that technology. Here what we are expecting this machine learning model to do is, here also we will train machine learning model. We will train machine learning model by giving huge size of the data to them, and they learn from that data. And once they learn from the data, that way they will be able to do a prediction. Prediction in the sense, we will train them on the data till yesterday. It can be business data, it can be sales data. We will train them on that data, and once they get trained, they will be able to do prediction for future. So you may ask them, what will be the sales next month, what will be the sales after 3 months, what will be the sales next year. So those predictions they will be able to do their performance, their accuracy in the prediction highly depends on one of the factors is the accuracy of the data they have been trained upon, this volume of the data they have been trained upon. They must be trained on the sufficient size of the data. They may be trained on all types of data specifically needed for specific prediction. Okay, and once they are properly trained, then we will have to evaluate them. Evaluation is the same way, student attempt the examination, and in case if students can score good in the examination, similarly these models are also to be also to be doing good in their examination. We call it as a scoring. So we will have to see how much score they achieve. Okay, that is called as a testing, test run also. Okay, so first of all, we will train the model, then we will test the model. And once we realize that the model is, able to give us enough good performance, thereafter we will use that model to do predictions. So the life cycle again is, first of all, get the accurate data. First of all, clean the data. First of all, transform the data. First of all, transform the data and align the transformation of the data, making it suitable for training purpose. So first of all, working on the data is a first step. Okay, we call it the data of wrangling, data munging. And once we munge the data, once we wrangle the data, thereafter that data becomes suitable for training purpose. And thereafter we will use that data to train the model. Let me just see second slide. Uh, no. Uh, okay, let me mention these steps here in the notepad. So steps, first of all, data preparation. In data preparation, we have to clean the data, transform the data, normalize the data. Normalize the data, it means bring whole data into same scale. Okay, for example, some of the column in the data is in the unit of thousands, another column is in the decimal point. Then they both these columns are in the different scale. So converting the data which is in the thousands into the decimal point, okay, in the similar scale of other column, okay, that is called as the process of the normalization. So you have to normalize the data. That way you will make your data ready for the training purpose. Then train the model. Train the model. Now here they already have written some of the algorithms. We call them as algorithms. Okay, algorithms actually is something which is nothing but the model, but short of being a model. Okay, so algorithm basically is the word algorithm suggests you somebody already has written a code for that, that. Okay, and that code has been written within the class of any programming language. There is a class concept and object concept in Java, class and object concept in Python. Okay, so similarly, algorithms have already been written into these classes. Okay, and you have to instantiate that class, you have to convert that class into the object. Okay, and that object then you have to use for the training purpose. So this class and this object is exactly same thing. That's what you understand as a class and object in any programming language. So here, once you train that algorithm, okay, then we call it as a model. So there are different algorithms available. You have to, create their objects, and you have to train these multiple objects, okay, with the same data, because just select one algorithm and train it, okay, will not give you sufficient performance. So what you have to do is you may have to use a different and different algorithms, create their objects, train them. So you may be creating, around 30, 40 objects. You may be training them. Okay. And then you may be calculating their performance or accuracy, and there you will realize accuracy of a specific algorithm is really high compared to all other algorithms. Okay, here it is not possible for anybody to anticipate well in advance which algorithm will give you best performance. So you have to apply a kind of a trial and error method here, where you may have to create 10 to 40 models. Okay, train them on the same data, and then and thereafter calculate score of accuracy for every model, and identify which model is the best performing. So training the model, basically process of, okay, training the model using data on the data. Uh, Once you train the model, around 50 models maybe, then you have to identify which model is best performing. Okay, so for that purpose, for every model, you may have to apply test process there. Test test processing, test the model. So in testing the model, you calculate score accuracy of every model. Calculate accuracy of each model, and then the model giving you best performance. Okay, evaluate the models. So you will calculate the accuracy of every model, and the model with the highest accuracy anyway, you will have to use for the production purpose. So compare different models for accuracy. Compare different models for accuracy. Okay, to find best per, performing model. I would like to know whether this font size is readable, or shall I increase the font size? Let me increase the font size. Please increase. Okay, okay. Yeah. So let me just view, zoom. Now I hope it is readable. Hmm. So evaluate the models, compare different models for accuracy to find the best performing model, and then you have to deploy the model. So you have got the best performing model. This model is in the form of in a language object. If you are using Java environment, it will be a Java object. If you are using Python environment, it is Python object. Okay, so objects anyway, you are aware that Python a object basically is an in-memory representation. Okay, so this is in-memory representation. Okay, you can serialize that object. In case if you are using Python, then it will create a pickle file. In case if you are using Java, it will be a CR file. Okay, and that file, pickle file or ACR file, then you can use for the deployment. Now, up to here, you are using development environment. So let me name it as a ML development environment. ML development environment. Okay, I'm not able to view it a tab. Now let us talk about deployment environment. Deployment. Both these environments are different. Teams are also different. Development team is different. Deployment team is different. Deployment team is comprised of different types of development deployers. Deployment environment. And there you have to deploy that model. It means you have to create in-memory production implementation of that model. It is basically to create in-memory production, okay, environment uh, for model. Hmm. So this environment is different than this environment, uh, than this environment. This environment which involves a very large data, lots of models are to be created here. Train the model, okay, process of training multiple models on the data, on the same data, multiple models on the same data. Yeah. Okay, so multiple models are to be created. The process, runs for many hours. Okay, and it needs a large hardware also. So this particular step, okay, needs a large hardware. Okay, and that's why these steps are costly and cannot be frequently done. But once you identify best performing model, okay, you will deploy that model, and perhaps this environment is less costly compared to development environment. And thereafter then that model can be consumed for different types of predictions. So mainly these are the two steps, and these are the two main steps, but these are all sub steps, and all these sub steps in this order comprise the life cycle for machine learning. These steps in the same order comprise the life cycle for the machine learning. As far as Azure machine learning is concerned, you do not have to have so large hardware here, because your hardware anyway is highly scalable and existing on the cloud. So that's why compared to on-prem environment, okay, of machine clusters, storage of the data, okay, and putting all the machines into run, to create 50 different models, that is certainly a costly business compared to having this environment on the cloud. Okay, so similar kind of environment is there in Azure. Similar kind of environment you will see in SageMaker of Amazon. So every cloud does have similar kind of solution. Here we will talk about Azure, and in Azure ML is a similar kind of solution. It is scalable, on-demand compute. It has different types of computes. We will see the list of the computes available here. It has its own storage also. Okay, and it's a very easy to access this storage. Okay, while training the model. ML workflow orchestration. There is a ML workflow which is platform ubiquitous API available, package available. It is available in Python. It is available in other languages also, and it is platform ubiquitous in the sense that on Azure, in case if you want to do machine learning development, you have three services, rather four services, I will say. Azure ML is in a service dedicated for ML development, but besides this, you can do machine learning development in Synapse Analytics. That is the second solution available. You can do machine learning development in HD Insight. That is a Hadoop platform. And you also can do similar development in Databricks, Azure Databricks. So there are four services where you can do development. Okay, let me list those services also. Okay, yeah. On Azure, following services are available for ML development. Azure HD Insight, Azure ML Service, Azure Synapse Analytics, Azure Databricks. Databricks. Yeah. So here we will focus on Azure ML Service, because Azure ML Service is offering you end-to-end solution for machine learning development. So, but on all these services, not only for Azure, but on other clouds also. ML workflow offers you orchestration. Okay, it offers you orchestration. Now we will try to understand more about ML workflow as we will move ahead. Okay, once the model is identified and best performing model is identified, that model can be registered for other teams to access. Specifically, I told you that development team is different and deployment team is different. How a model developed by development team is becomes shareable to the deployment team, so their model is to be registered. Okay, and it can be managed for different versions also. Then deployment team will get access to that model, and then deployment team will create a deployment environment and will deploy that model there. So deployment of the model is again very typical and a peculiar process. Okay, so it's not like other deployments. Okay, it has own nitty gritties here for Azure machine learning models. Metrics and monitoring, you need to continuously monitor the performance of the model. So the production team managing production environment will keep monitoring the performance of the model. And when that team realizes that the performance of the model has been degraded because of drift in the data or for any other reason, then development team certainly is informed. Okay, and development team has to go back to the step one, okay, in that life cycle, and rerun those steps. Again, new data, it has to acquire, clean the data, transform the data, train the model on the new data, okay, test the model, increase the performance, identify best performing model, okay, and then submit that model for the deployment team for the deployment purpose. So on Azure machine learning, it offers you end-to-end development. Okay, it can procure data from many types of storages. It can apply data transformation. Can yeah, different data transformations can be applied. For data transformation, we do have HD inside Databricks. Okay, we also have something called as the data factory. Data Factory offers you different ways of data transformation without writing any code. So it's a completely graphical platform where without writing a code, you can transform the data. That is Data Factory. Data scientists can work on this Azure machine learning service. Just a minute. I think I have got some messages. Maybe let me just check. No. Yes, Balkrishnan is there, I think, who wanted to connect. Is it there? Just a minute. Huh. Balasundaram. Okay. So data scientist can use machine learning services in case if data scientist is from development background. Data scientist may choose to do to implement machine learning life cycle pipeline using say Python code, or in case if he wants not to use a Python code, okay, still he can do the data science, okay, by using no code or less code approach. That is also possible. Software engineers and operators also can work with it, okay, for deploying the model and for making the model ready for say consumption. Okay, different applications thereafter can consume that model, or ML powered apps, app services there. Azure functions can use it. IoT Edge can use it. Okay, so different types of application services are available, which are supporting to overall machine learning development. The model can be deployed on different container platforms also. So container instances or Kubernetes instances. So your deployment team may use one of these services here, like Kubernetes service, to deploy the model and make it available for production purpose. ML ops is there. here what happens, after some time with some drift, some change in the data, we realize that the model performance degrades. And it happens in almost every case. The model performance degrades because this world is changing so fast. The data trends are changing. The challenges in the market are changing, because of which the model needs the retraining. Okay, after some interval. This interval in some cases may be a week's interval. In some cases it may be a month interval. While in some cases it can be even interval of 6 months. But after that interval, you have to push the model into the same life cycle of retraining it on the new data. Okay, testing, scoring, evaluation, all the steps are to be carried out. And that process of automatically pushing that model into training purpose, okay, that is called as a ML ops, ML operations. Okay, so automatically pushing that model into the retraining phase, okay, is can be made possible by using ML ops. I already gave you brief introduction to ML flow. Here MLOps uses, or MLOps can be implemented using ML flow. So ML flow has really a great significance. Not only it is a platform ubiquitous, but that can be used for continuous integration and delivery. ML flow can be used for continuous integration and delivery, and it can be used for implementing ML ops life cycle. As far as Azure Machine Learning Workspace is concerned, on Azure, you have your subscription. There you create a resource group. And inside the resource group, here you create workspaces. Workspace. Inside a workspace, you can manage a compute. There are notebooks, there are pipelines. Let me show you the workspace that I have created. Here it is. Here is my workspace. Okay, I created it in Azure. Here is my workspace. I already have created it in Azure, and when I clicked here, it did open something like this. Okay, and inside this workspace, I can manage my notebooks, designer pipelines. I can automate ML. I can manage my data, jobs, components, environments. Deployed models also can be managed here. Okay, see here we can manage compute also. We can monitor the things. Okay, so everything that is needed is at one stop, and that is Azure Machine Learning Workspace. Okay, so here we had a look at machine learning workspace. Let me open it again. Just a minute. Let me take this ribbon, right side. Let me open it again to show you. Once you create it, how can you open it? So here is Azure Machine Learning Workspace. And from here, I have to launch it. Like other services, we can create this service also, the way you create Azure storage, the way you create other services, you have to create Azure ML workspace also. By clicking here, I am launching the studio. So this is a different portal, and on this portal, end-to-end ML development can be done. So here you can see model catalog also, which talks about generative AI models. Here you can see GPT models, generative AI models. Okay, but here in our discussion, we will not go for generative AI, but other components can be managed here. You can see here. Um, just a minute. Uh, IPyNB files are appearing. IPyNB files basically are for uh, Python code. Diabetes test batch pipeline. I think here I have. Here is one of the notebooks available. Notebook not available. Let me refresh the screen. Yeah, now it is available. So notebooks, you can see here is a Python code. I will briefly introduce you to that Python code also. There are designer pipelines also. Some of the pipelines I already have created. This is completely, um, you know, GUI based arrangement. Okay, so here also you can see one of the pipelines. Let me show you the pipeline loan data, for example. Let me just check. Yes, this is graphical tool. Okay, I have to simply drag and drop every action on this canvas. Okay, and then when I put it to run, it creates a model. So this is now in this tool. Just observe. Here I am getting the data from my data set. Okay, I may have to apply some transformations. Okay, so some of the data cleaning measures I may have to apply, some of the mathematical operations I may have to apply, some normalization operations I may have to apply. Okay, but this is like a drag and drop without writing any code. Okay, edit the metadata, select the columns for the data set, clean the missing data. Okay, split the data. I may have 100 records, out of which I may want to use 70 records for training purpose and remaining 30 records for testing purpose, for scoring purpose. So here I may be using logistic regression algorithm. So logistic regression algorithm I am using. Okay, to that algorithm I am submitting the training data, and here I will get trained data, a trained model. Okay, and to that model then I may apply testing data to identify how many correct answers out of 30 training data, sorry, testing data we may be giving to it, and it will decide the accuracy of the model. So here we will calculate the accuracy of the model. Here we may say use multiple models for the comparison. Here another model for the comparison as of now is not appearing. Okay, but we can do a comparison among the models or between the models, and to identify best performing model. So this approach, seems to be really easy. It allows me to apply different transformations on the data, and thereafter we may use that data for training or testing the models. Okay, this is no code or less code approach available. Okay, so finally, whatever model we get, that model can be used for deployment purpose, for production purpose. Okay. If I take you to the notebook, now in the notebook here you can see, I will take you through the code. I do not expect you to, or even if you also do not try to understand the code, every code. Okay, but here your purpose and my purpose basically is to give you glimpse of how a development can be done. Okay, so here, first of all, let me make my compute ready. Okay, so let me show you more about the compute also. I will come back to this screen little later. First of all, let me show you different types of computes available here. So you can see there are 5 types of computes available here. The first one is the compute instance. This compute is a kind of a virtual machine, virtual computer, virtual CPU, you can say, which we can use for the development purpose. So execution of the Python code in the notebook, okay, can be made possible here. Let me select this and let me start it. Okay, so this compute is like my laptop, okay, where I may be doing some development. There is another type of compute available to which we call it as a compute cluster. Whenever you are working in the team and you want single so strong compute, so that in case if 10 members of your team are working at the same time, Everybody should sense that compute is working for himself or herself only, and it's not being shared by others, because that compute offers compute service to everybody, because that compute has its own cluster. Okay, and for everybody's work, it works. It provides services in isolation. So whenever a big team is working, okay, there you can use a compute cluster. Sometimes single person is working, but he would like to go with a compute cluster because of very heavy workload. In compute instance, you will get a single instance. When you want a cluster or big data processing, there you will go with a compute cluster. Kubernetes cluster is also there. This can be used for say deployment purpose. Attached compute, in case if you do not want to use any compute from here, but you want to use up and running compute of Databricks, up and running compute of Hadoop system is the insight. That also can be pulled here, okay, and your workload here can be submitted to that compute also. And for on-demand workloads, okay, for abrupt execution of the workload, serverless instances are also available. So my compute instance is up and running here. Now let me go to the notepad, notebook, and let me put the code to run one by one. So here it is simply getting, say version of the Azure ML service, and we will have to wait for a while. Your compute is ready. Your Azure ML version, say environment is ready on this compute. So here is the 1.57 current version of Azure ML. Okay, here you are logging some message. You are enabling logger to log messages over there. Okay, and now here you are getting access to the workspace, because in the workspace a number of things are there. Okay, so you have data over there. You have environments over there. You have models over there. You have notebooks over there. Anything if you want to access in your Python code, for that purpose, you need to connect to the workspace. Remember, as of now, this code we are running in Jupyter notebook or Monaco notebook, available in the same portal. But that may not be the case all the time. You may want to do the development not in this Monaco editor, but you may want to do the development in Visual Studio Code. Okay, there, then getting an access to the workspace is important. So let me put this code to run. Okay, and from the workspace, different components, if you want to pull, okay, and work with them, that is possible. So yes, I have got an access to Chandra ML workspace here. Okay, I can see different details of that workspace. What is the name, in which region we created the workspace. Okay, this is an API which we can use to access the details of the workspace. Okay, so there is a it's a API to access the number of computes over there. Here you can see this code can bring me details of the workspace. If I put this code to run, okay, it will bring me the list of all computes available. So one compute we already have created and we already have started. So that's name is appearing. So there is a API code available to get the list of the compute. Here is the API code available to get the list of the data sets. Yes. So these many data sets are available. So data sets again are, it can be CSV file or it can be any other file registered with Azure Machine Learning Service. Okay, and Azure Machine Learning Service may, convert that file into a suitable data format that is called as a data set. Okay, so Chandra data set diabetes that we will use here. So that data set is already existing. And hereby now I will get an access to that data set. Okay, data set to pandas data frame. Remember here we are doing analytics, so we need a data in the format suitable for analytics. We don't need the data which is in the tabular format, table of the database or something like that. We need a data suitable for analytics. So let me put this code to run, and here I will get the details of the data set. Now this is a data set for any patient. Okay, whenever one is represented, it means this patient is diabetic, and here are all the pathological parameters for that data set, for that patient. There is another patient. Okay, that patient is non-diabetic, and its pathological parameters, right? Glucose, blood pressure, skin thickness, insulin, BMI, and other things. So this data set we will have to use to predict whether a patient is showing symptoms of diabetes or not. So for any patient, we will submit this pathological data up to this column. And we do expect from that model to predict whether that patient is carrying any diabetic symptoms or not. But in the phase of the training, both all these columns we will have to submit, including outcome, whether that patient is diabetic or not. All these columns we have to submit to train the model. Yes, so here we are splitting the columns, not the data, but the columns. Okay, these many columns are called as a say feature columns on which your model is expected to work to do the prediction. Okay, so this is going to be a pathological data to be submitted to the model so that model will do the prediction. Okay, whether that patient is diabetic or not. So the columns on which it has to do the prediction, these columns, they are called as the feature columns up to this, and the column which is nothing but the outcome of its a prediction, that is called as a label column. So this is label column, which will which will be a kind of a prediction. So feature and label columns are to be splitted here, and thereafter, okay, from the feature and label columns, here we will have to get training data set and testing data set. So whenever I mention test size here, okay, so 30% of data we want to be in the for the training, testing purpose, and remaining 70% is for training purpose. So we are splitting. Earlier we splitted data column wise, okay, as a feature and label columns. Here we are splitting the data row wise. Okay, so 30% of the data, 30% rows are for training purpose or testing purpose, and remaining 70% are for testing purpose. Correlation. This is very important concept. Okay, in the machine learning. Okay, whenever you want a prediction of whether the patient is diabetic or not. Okay, what are all parameters contribute to that decision? Okay, of a patient is diabetic or not. What are all columns? So from here it is pretty clear outcome. From here it is pretty clear that glucose is highly contributing in making decision. Okay, of predicting whether patient is diabetic or not. BMI is also another important factor. Somewhere age is also important factor. So dark blue, faint blue, further faint blue, they are deciding how much outcome is depending on these columns. We call it as a correlation. Yellow color, it means okay, it is very less contributing, very little contributing. Okay, but blue color means they are highly contributing. Okay, so thereby here we will decide, for the prediction purpose to submit only those columns, okay, which are useful for it to give correct prediction. Yellow columns here we may not be now this kind of yellow anyway we will not submit to it. Okay, but here all these columns perhaps are more or less contributing. Now this is contributing around 30%. This is contributing around 47%. This is also contributing around 6%. This is contributing around 7%. Okay, so those columns which will contribute in decision making, Okay, those columns you will have to submit. But how we will decide which column are contributing? So there, then we have to see this. This is called as the heat map. Okay, which gives me the idea which columns to be selected for that purpose. Okay, how many records are there in training data set? Let us see. I think I forgot to run this code. I think. Just a minute. Uh, Let me run it from the beginning. Here I have got it. Second step, third step. Yeah, it is also executed. Fourth step, yeah, it also got executed. Then let me draw a heat map. Hmm, Yeah, then this step. Okay, how many records are there for training purpose? 537 records. Now this step is really important. In this step, hereby we are asking you to use logistic regression algorithm. And we are submitting some hyperparameters to it. So hyperparameters also contribute heavily in the performance of the model. So algorithm, pyramid data, and hyperparameter. These are the three very important things uh, to achieve better performance. So here we are submitting a hyperparameters also to it. Here we are calculating the accuracy of the model, and then it has to show me that accuracy. So again, hereby I will ask it to create a pickle file of the model that has been created. Name of the pickle file has already been given here. It will have to create a pickle file and it has to serialize the model so that that model later we can use for the deployment purpose. So once I put this code to run, okay, then it has to show me the accuracy and accuracy is 78%. So 78% is not bad, but it is not good also. Then what we have to do is we may have to run this code by changing the hyperparameters, but for the same algorithm and every time calculating accuracy. We may change algorithm also. Here it is logistic regression. We may use random forest or decision tree classifier. There are different types of algorithms we can use, and you will realize for every algorithm or every hyperparameter set, it will keep giving you different and different accuracies. So this particular code you may have to run 100 times. You are being a data scientist. Okay, you may have to run this code 100 times by giving it different sets of hyperparameters and by giving different algorithms. And then for every algorithm, you may have to record its performance, its accuracy, and then you have to identify which combination of the algorithm and which combination of the hyperparameters gives you best performance. So this step is basically very rigorous, time consuming for data scientist. Okay, but data scientist anyway cannot anticipate that this specific algorithm and this specific hyperparameter set will anyway give them best performance. It is not at all possible to anticipate. Okay, and that's why this is some way a trial and error what data scientists will have to follow. Okay, and run these steps hundreds of times to get different and different models with a different and different accuracy. And every time, for every model, for every combination of the hyperparameter, they will have to keep a track of the accuracy what you have got, what has been got. Okay, to decide which model is which combination of the algorithm and uh, hyperparameter is the best performing. Okay, yes. Once you get that pickle file, here you have got accuracy. Here you will get the pickle file name. It has been already stored in the storage. That can be used for the deployment purpose. Again, here I do say I have missed mentioning the steps to do the deployment, but otherwise there are programmatic steps also which we can use for the deployment purpose. But this is the way you have to write a Python code, and this is definitely a very strenuous work, to run these steps repeatedly for different combinations of algorithms and hyperparameters to identify best performing model. Okay, so this is programmatic approach. I already have shown you designer approach also. Now it is the time for us to come to automated ML. Okay, so let me go to automated ML now. Now here in automated ML, okay, what will happen? Let me tell you. You do not want to do development because I already have brought to your notice how strenuous it is, for the data scientist to run that code and keep a track of, which combination is offering them best performance. In automated ML, without writing a code, okay, you can make everything possible, and it is also in very less time with a very easy way. Okay, so here, what I suggest you to do is to uh, let us begin with automated ML. So let me create a new ML job. Okay, so here I click. Okay, but before I go for the automated ML, let us quickly understand fundamentals of automated ML. I will come back to this uh, slide little later. Uh, okay, we already have gone through machine learning studio. We already have gone through this type of code. Okay, this code writing, okay, we might have made it possible in Monaco editor, but otherwise this code writing we can make possible in Visual Studio Code also. In case if you are already using Visual Studio for the development, that approach will help you a lot. Okay, let us understand more on automated ML. Train multiple models in parallel. Now I already told you that you know around 40, 50 models the data scientist will have to create. He will have to keep a track of performance of each and every model. He has to keep a track of how he has got, with what combination of the algorithm and the hyperparameters he has got that performance, so that for the production purpose same combination, okay, he may have to use for the production purpose, because that combination anyway is performing best. No, if you, being a data scientist, if you create one model, record its performance, then another model, record its performance, and in case if you want to do this for around 40, 50 models, it will be very strenuous job of maybe a week or so. A data scientist may take a period of a week, to find the best performing model. Here in automated machine learning, what happens that you may have to create a cluster, and whenever cluster of nodes, and whenever you ask it to use the different algorithms with the different combinations of the hyperparameter, okay, it will create n number of models on different nodes in that cluster, and within an hour or so, I'm not talking about even a day, within an hour, or two at the most, he will get a best performing model identified. That is the say beauty of automated machine learning. You simply have to submit the data to it. You simply have to configure the things, that through portal or through program. Through program also you can configure automated ML, but through portal, if you do not want to write a code, Python code, okay, through the portal also you can configure it, and thereafter It will apply varying algorithms. Okay, it will do its activities in parallel on different nodes at the same time within the cluster, and pre-processing find the best model based on the specific performance matrix. So this kind of screen you will get when you will go for the automated machine learning. You will have to select the data set, you will have to configure run, okay, task type and settings. So whether you want to go with the classification machine learning, regression machine learning, that you will have to decide. Okay, the example of diabetic patient, yes or no. Okay, only two classes, diabetic or non-diabetic, only two classes. So that such algorithms are called as a classification algorithm. But if you want to do the prediction of the cells in the next month, that is a figure. That is not some kind of yes or no. Sales prediction. How much sell company may do next month? That is a numeric figure you are expecting. That is called as a regression algorithm. If you are expecting yes or no, it is classification. And if you are expecting figurative prediction, then it is a regression. If you are doing a prediction on the time series, okay, then that is a time series of prediction. So there are different types of algorithms, and you have to select exactly which kind of life cycle you want to run. Configuration and featureization. The configuration options, you will have to configure a primary metric. You will have to create explanation for the best performing model. You do not want to go with some of the models because there are 15 different models. Some of the models, anyway, you are refusing at all because maybe those models are not suitable for your hardware or the environment that you are working in. Okay, so those models you may be rejecting at all at the beginning itself. Okay, and whenever it starts training the model, okay, it may have to create a 40 models, 50 models. Somewhere you have to decide when to stop. So exit criteria, that also you will have to define. When do you want it to exit? After finding the n number of models or after achieving the expected accuracy, that you will have to decide here. Okay, validation, what type of validation you want to apply, whether it is train and test validation, whether it is a K cross validation, and number of validations are also available to identify the accuracy of the model, and then parallel number of iterations, what you want to, how much quickly you want it to do the processing. Featureization, normalization, I already explained you about normalization, bringing all the column values into same scale. Okay, so dropping high cardinality features, imputing missing values, categorical. So these things you can configure there. Okay, in the process of automation. Okay, so let me take you to the automation now, and here I am. The very first step basically is to define the data set, basic settings. So job name. Let me ask it to create a new job or select existing job. Huh. Okay, diabetic experiment. Or let me ask it to create a new job only. Diabetic experiment one. Yeah. Any description you can mention. Okay. So clicking on the next. So no Python code anyway, I will be writing here. Select the task type. We will go with a classification as we are planning to go with a diabetic or non-diabetic data set. Okay, so that's what we will go with. But otherwise, what are all different task type that you can see? Natural language processing. Okay, to identify any sentence written in English, for example. Computer vision, to identify images, to analyze images. Object detection in the images. Segmentation in the images, that is computer vision. These two talks about deep learning. They do not talk about machine learning. They talk about deep learning. While initial these three are talking about machine learning. So we will go with a classification. Yes. And let me select the data set. Uh, Chandra data set diabetes. Let me select it. Okay, I already shown you the data in our when I introduced you to the programmatic code. Clicking on the next. So we have set the data here, which from which data set it should bring the data. That also we define. We did define. We also define whether it is a classification or regression type of machine learning. Okay, so task type classification. This is the data. Target column. Target column is label column, the column which you want to predict. So that column we are supposed to select, and here it's the outcome. 0 means non-diabetic and 1 means diabetic. So target column, that's let me. Huh. Now here we are not using natural language processing or uh, say image processing. So we will not go with a deep learning. In case if you want to do additional configuration, okay, that is also possible. View additional configuration setting. Okay, uh, on which performance there are a number of performances available: AUC weighted, accuracy, average precision score weighted. Okay, but here we will go with the accuracy of the model. And here, in case if model has an accuracy beyond 90%, okay, we definitely would like to go with that model. Okay, yes, use all supported models. No, here we will select only few of the models as we have less time. So allowed models. So here let me go with KNN, decision tree, random forest, extreme random forest, and light GBM. These different algorithms are available for classification. So here is a complete list. Okay, out of this list, okay, may not be every model we will decide to go with. Okay, these many models. Let me select XG booster also. Okay, these models let me select, other models let me drop. Uh, yes. And after this, let me save this configuration. These models only I am selecting for it to, create n number of models. Save. So that configuration I did. Featureization setting. So these are different columns available. Enable featureization. So it is already checked. Enable featureization. So here we will. Now here you can see this glucose level is in the range of say 80 to 300 or 400, sometimes it may be 500. Okay, but BMI index is in points. So they are in the different scales. Okay, and in normalization, we are expecting them to be brought in the same scale without changing their properties. Without changing their properties, that means what it will do is to the BMI, it will multiply all BMI with a 10 to bring it in the scale of the other columns, scale of other columns. It may apply, multiply it with a 10, okay, but to bring every column value into the same scale. Diabetes pedigree functions, they are with a range of 0.627. Okay, so here what I see is that instead of multiplying with what 1000 to bring it in the same scale, ideally what it may do is it will convert every value into decimal point. Okay, so it may divide it by 100, it may divide it by 100, so that every value will be brought into this scale. Okay, but somehow either it will multiply or divide, okay, to bring all the values into specific scale. So let's go with it. Validation and test. Validation type. Validation type. Let us go with a train and a validation split. Just a minute. Huh? Just a minute. हॅलो प्रशांत. हा प्रशांत, मी थोडा एक सेशन मध्ये आहे, मी तुला कॉल करतो संध्याकाळी. येस येस. Sorry. Okay. So here we are asking it to divide the data, okay, into two parts, one for training purpose and another for testing purpose. Okay, test data, yes, train test split, and here we will mention 20%. So 10% maybe for this is basically for calculating the accuracy of the and the performance of the model. Okay, so testing that also is configured, and now here it is asking me which compute to be used. So we already have created compute instance. Ideally, if we go with a compute cluster, it will incur more cost, but it will complete this job in less time. Okay, here I already have created compute instance. So let me select compute instance. Now in this compute instance, okay, there are already two CPUs. Fine, two CPUs are already there. Okay, so anyway, here on this compute also, uh, on these two CPUs, it will do concurrent execution. But in case if I select for compute cluster, there will be multiple nodes with every node having multiple CPUs. So I will get wider compute in that case, but it will take a longer time for me to create such a cluster. Okay, and also it will incur the cost, but as time is uh, a major hurdle here. Okay, I will go with whatever compute we have created. I'm clicking on the next and submitting the training job, and now it will start the automated ML. Okay, so in automated ML now it will create the models one by one. It will apply different normalization technique on the data for that model. Okay, and it will calculate accuracy for the every model, and thereby it will list performance model wise. It is going to list performance model wise. So everything we will see here. And once we get a best performing model, that model we can register here on the ML registration service. Okay, so that that model can become accessible to the deployment team. So in case if time permits, we will see how we can do deployment also. But as of now, it has started working on the models. It has started working on the models. Okay, so models and child job. Let me go here. Okay, and hereby now you will see when it creates a model, when it scores the model, that model will be listed here one after another. That model it will keep listing here. Okay, so let us see how does it work. Nowhere I have written a code without writing even single line of a code. This automated ML will create a different and different models, will arrange these models in the descending order of their accuracy. In descending order of their accuracy, it means at the top, it will always keep showing me best performing model. For every model, algorithm what it has used, normalization technique what it has used, what are different hyperparameters it has used, what pickle file it has created, everything will be recorded here. Everything will be recorded here. So the job of the data scientist has been extremely simplified here. Extremely simplified. Even if you are not a data scientist, but if you want to train and identify a best performing model, this tool is helpful to you. Although there are pros and cons, in case if this tool is a great solution and final solution, why people still use programmatic approach? That may be a question in your mind. The programmatic approach offers you a high degree of customization. That's why people still use it. This is an approach where customization is limited. See, first model it has created, now it is calculating accuracy. And once it completes calculation of the accuracy, that also it will show here. So light GBM is a model what it has used. Okay, and max ABC scalar is a technique what it has used for normalization. Huh. So its accuracy is 75%, and that seems to be good, but not best. So now it has started creating another model, XGBoost classifier. This is another model. Okay, here you can see hyperparameters also. Okay, with what hyperparameter combination, it has created this model, that also you will be able to see. Okay, so another model is a XGB classifier. Now it is calculating its accuracy. And see, two models as of now it is working upon, because there are two CPUs there. That's why concurrently it is trying to create multiple models. Then the third model is using the algorithm extreme random forest. Okay, still I can see light GBM model is at the top because it is offering better performance than other models. If I scroll it down, yeah, XG booster with a different normalization technique and with a different set of parameters maybe, okay, is offering less performance. Hmm. So this is how it will keep giving you, creating multiple models for you. Light GBM with a different set of hyperparameters. Let us see. Hmm. But the point is, this is how multiple models it is creating. We can speed up this process in case if we, as of now, we are using instance, a compute instance. If we try to use cluster, you will see the process can be speed up. Okay, but the point is, okay, the steps will be similar even if we use complete say cluster. Only process will be speed up. Okay, still I think no. Here we have got another light GBM model with 79% performance. So somehow I am getting models with a better and better performance. So let it take its time. In the meantime, let me take you through slides. Okay, we already have gone through designer. Okay, I already have taken you through uh, designer page. Okay, and designer also is a very less code approach. Here you can write a code for some customization, okay, but that code will be minimal. You simply have to drag and drop activities onto this canvas, okay, and thereby build a pipeline. Okay, so designer approach is also good. Uh, Here it is suggesting to use a logistic regression. Here it is suggesting to use a data preparation. So simply you have to drag and drop these activities, and these activities are to be connected with a pipe. So you have to simply draw the pipes over there, and thereby you can do the development to identify best performing model. Then this is a step to deploy the model. So for deployment also, you don't have to write any Python code. Okay, that also is made possible through the designer. So deployment also is possible there. Publishing the service endpoints, real-time endpoint, batch processing endpoint. What is the difference between them? So when I have got, I am say medical practitioner, and I have got a pathological report of one of the patients. So I want to use this particular service. So on my screen, there will be web application. I will enter pathological data into that web application. That web application will submit that pathological data to the model, that best performing model that has already been deployed on the cloud. Okay, so it will submit that pathological data to the model in the form of the JSON object. Okay, I mean to say in the through the REST service, REST, REST services. I hope everybody knows REST services. Okay, that will be submitted to that model, and that model will create its response of the prediction again in the form of the JSON. Your web application inside which you are doing a call to the REST services, receiving the submitting the JSON, receiving the JSON, okay, by using maybe JavaScript, okay, will pick up the prediction done by that model and will populate it on the web page. Okay, so that way JavaScript can be used in web application to create a REST request and receive the response. Any application, not only web application, any application can create a REST service. Even Python application also, if it is a Python application which wants to get a prediction done from the model, in that Python application, you simply have to create a REST request, submit the data through the JSON, receive the data in the form of the JSON, receive the prediction in the form of the JSON, and use it for the application's purpose. So in the applications, on the web page, everywhere, you can consume the prediction from the model. This is for a single, say, patient. Now consider that I have got we may have conducted a camp in the say remote area where internet was not available, and we got data in the form of the batch of the records. Then we will have to use the same model with a batch pipeline. We'll have to deploy it for the batch. Okay, the deployed model for the real-time endpoint may not work here for a batch endpoint. We'll have to create a separate batch endpoint, separate deployment environment. There, maybe we have received data of 50 different patients. Okay, we will have to submit all these data of all these 50 different patients as a batch to the model. Model will create a document inside which for every patient, what is its prediction, for another patient, what is its prediction, everything will be mentioned there. And you will receive that response again in the form of the batch of the records, maybe inside the file. Okay, so that is batch pipeline. Let us go back there, and also let me see, have I received any question? No question. Huh. Okay. And what is the progress of our work? That also let me see. It is still running. It is still creating different and different models, but let me check. Till to the time, light GBM model is the best performing. Okay, and still it is creating the models further. Excuse me. So it will take next half an hour maybe for completing its process. But as of now, this is one model which I have got as the best performing model till to this time. I can go to this model. Here I can see its hyperparameters. These are the hyperparameters, what it has submitted, maximum being maximum depth and other things. For every type of algorithm, there are different sets of hyperparameters. For light GBM, okay, it has maximum bin and maximum depth, also learning rate and other things. Okay. Uh, and if you want to deploy this model, in case if this is the best performing model, what we have got, and we are okay for its deployment. So from here, we can deploy it as a real-time endpoint. The production environment for real-time endpoint is different, and production environment for batch endpoint is different. That's why real-time endpoint deployment may not work for batch endpoint deployment. So you will have to, create a separate deployment for batch deployment. So from here you can do the deployment. On which environment I told you that development environment and deployment environment are different. So if I select here, okay, here which kind of cluster to be created? So maybe 3 node cluster we want to create. This is a new endpoint. So somewhere here, deployment environment we may have to configure. Okay, here, uh, yes. Okay, virtual machines, which type of virtual machine to be used. Okay, now here the important point is how quickly we receive the response. It should not take a minute or so to create a response. So whenever you configure this environment, okay, you will have to bother about the latency. In the development environment, you may not bother about latency, but here you have to bother about latency. How quickly you receive the response, and accordingly, then you have to, create here compute environment. Okay, if you see the 3 nodes perhaps will not be sufficient. Okay, you may have to increase the number of instances here depending on how many REST requests are hitting to this environment for the prediction purpose. More or the request per second it is receiving, definitely you will need more wide environment. Okay, so that's what you will have to configure here. Okay, and then you may have to click on the deploy. But here, before I begin the deployment, let me go back here. It is still running. Let me just check here how many. Has it identified any new model with a higher performance? Fresh. Or otherwise, whatever model it has identified as the best performing model till to this time, that can be put for the deployment purpose. Yes, it has identified random forest model with 82% accuracy. Now, sometimes what happens that the agreement what you may be having with your client for whom you are creating these models, in that agreement, it might be mentioned that they need performance of the model more than 90%. Then perhaps selecting this model will not be good idea. You will have to wait until you get a model with a better performance. But in case if they have mentioned there that performance, 80% performance is okay, then this model you can select for deployment purpose. And here if we wait for next maybe 15-20 minutes, I'm pretty sure we will get a model with a 92%. Okay, because I already have tried with this, and yes, there is a best performing model with a 92% accuracy. But anyway, as we are running out of the time, okay, so let me show you how can we deploy this model. And let me deploy this model now. And from here we can deploy. We will register this model with a registration service. Okay, from here, in case if we want to make this model accessible to others, including deployment team. But here, instead of registering it for anybody else, let me deploy it for real-time purpose. And here, instance count 3. Let us use this machine. Okay, endpoint name, inferencing data collection, package model. Let me start deployment. But again, deployment needs a separate environment to be created. Okay, and because of that, it's a separate type of compute what it has to create. Because of that, it is going to take a longer time. Okay, but longer means how much longer? So maybe next 15-20 minutes. So overall process you are able to complete within an hour or so. Okay, but maybe by end of today's session it will not be able to complete it. Model deployment is successfully triggered. It is simply triggered. It is not, deployment is not yet completed. Huh? It is still deploying that model. Okay, so if I want to see that model deployment, I can go to the endpoint, and there it will show me, yes, this model is being deployed. If I go here to that model, okay, here you can see it is creating the environment for that model. So it is in the process of provisioning the environment for that model. That's how even deployment is also possible. And once deployment gets completed, it will give me the Python code or C sharp code, which I can copy paste into my Python or C sharp application. Okay, and that code creates a REST request, receives the response, and then okay, it is up to your succeeding code how to utilize that response. But here you will get testing environment of that model. Here you will get code that you can simply copy paste to consume the model. So hereby, it offers me end-to-end development. I have got one question. Real companies, I am right that IPyNB notebook might not be using, rather PySpark would be using because data is huge. Yes, yes, you are right. But one point I would like to bring to your notice. Here you are talking about huge data. You are talking about huge data. PySpark is separate API. Databricks uses it. HD Insight uses it. Synapse Analytics uses it. Okay, basically that PySpark is API Python API available. It is available in 5 or 6 languages. Let me talk about Python only. It is for huge data, but it is that API can be used in other uh, say other platforms. Databricks uses it. Okay, but it is separate API means in case if you want to do same thing there using PySpark, you will have to first of all learn PySpark. What if you want to do the same thing on the huge data using basic Python? So that is possible here. Here, though we are using Python, but this platform is offering you, same thing to be done on the huge data. So huge data is usable here only. Basic Python is not say scalable on for huge data, but the same Python here is scalable. In ML service, same Python is scalable. Okay, so even if it is a huge data, yes, it is possible. So you don't have to learn a separate library. They use basic Python only for your development. But otherwise, PySpark is something, till to the date, many people prefer PySpark. Because why PySpark? That whatever code you write in PySpark, the same code can be executed with minor changes on Hadoop platform, minor changes on Synapse platform, and very minor changes on Databricks platform. So the PySpark code, is workable even if you want to, migrate your code into other service. PySpark works there. Although this Python will not work in Databricks or on SD Insight. That's why PySpark is preferred. And many organizations are preferring PySpark because of its ubiquitousness across the platform. Okay, I think it is going to take a longer time. In the meantime, if you have questions, please go ahead with your questions. Let me go to automated ML. Uh, Pipelines, uh, jobs, as it is still running that job. Diabetes experiment one. Yeah, it is still running that job. Okay, models and child jobs. Okay, still it hasn't identified any new model with a higher performance. Okay, as of now, this random forest model is with a highest performance. Okay, so any question, please go ahead. Here you are simply deploying by a button, but I have heard things like CI/CD, Docker, Kubernetes, orchestration, etc. So what about all of those things in deployment? Yes, this is really a nice question. Okay, now I told you that in AutoML, you have limited scope of customization. Here, whatever environment it is offering, you will have to go with that environment. But otherwise, in case if you want to do the customization, then AutoML perhaps is not good for you. What you can do is you can create a pickle file of the best performing model and use that pickle file to deploy on the Kubernetes. Use that pickle file to deploy on the Docker. Use that pickle file to work with the CI/CD. That is possible. Okay, but you can use AutoML to identify best performing model very quickly. And once you get best performing model, then you can, use that model in other services. So this AutoML is actually keeping all complexities under wrap. Internally, it is using Kubernetes. It is automatically doing orchestration. Okay, so those things are not visible to you. Hmm. Huh. Now, what is a pickle file? Pickle file basically, see, here we are talking about creating a model. What is the nature of the model? The nature of the model is a in-memory object. If you are using Python, your model is a Python object. If you are using Java, your model is a Java object. This is in-memory object. How do you represent this in-memory object on the disk, in the file? So there you have to serialize that object on the disk or in the file. So pickle file is a serialized form of in-memory object, and it is a file. Okay, that file can be registered. That file can be attached to the mail to send it from one location to the another. That file becomes even transferable, transportable.